Hello.
Hello.
How are you today, Mason?
I'm fine.
Thank you for taking time out of your busy schedule. And for our
Okay.
viewers, I'm Stephen Perrineau, an analyst and partner at OrionX, a Silicon Valley-based technology consulting firm with deep roots in the HPC industry.
Okay.
And
Nice to
it's a
meet you.
pleasure to meet you. And it's my pleasure today to interview Dr. Mo Chen, who is Director of Solution Design at Huawei for enterprise storage, including HPC and big data applications. Dr. Chen is a member of the IEEE Technical Consortium on HPC, and Huawei's storage solution for high-performance data analytics recently won a Best of Show award at Interop Tokyo 2021. Huawei is also a platinum sponsor for the ISC conference. So my first question for Dr. Chen is, what do you think about today's developments in HPC, and where do you think the field is headed over the rest of this decade?
Okay. I'm Mason from Huawei IP product line, and I'm director of the solution. In my opinion, there are five main trends in supercomputing or HPC industry. That is cluster architecture, heterogeneous computing, data-intensive HPC, IP-based network, and application containerization, which will have a huge impact on the supercomputing industry and make conventional supercomputing upgrade from 1.0 to 2.0. First of all, in architecture, supercomputing is developing from massively parallel processing to cluster computing. More than 19% of the world's top 500 supercomputing systems are already clustered. Clustered systems are not only an enhancement of computing capability, but also share a similar architecture with data center. Therefore, new technologies like AI application and big data analysis can be deployed with HPC application simultaneously. Secondly, heterogeneous computing becomes the mainstream. Conventional HPC uses CPUs for double precision floating computing, whereas new systems use CPUs, GPU, and FPGA for much more powerful computing. System application has also expanded from simple scientific scenario to more conventional computing scenarios, such as auto-driving and genome testing. The third, but the most important trend is the data-intensive HPC. Larger data volumes, multiple data types, more parallel tasks, and higher reliability require HPC storage that can provide larger bandwidth, higher IOPS, higher reliability, and massive parallel access. Firstly, the HPC networks should be all IP-based. In the HPC center, RoCE and lossless data transmission technologies have enabled the computing network, storage network, and the management network to converge into one. Additionally, in order to share the resource, all IP HPC network is necessary. The fifth trend, in my opinion, is that supercomputing is being provided as a service. Both the Chinese Academy of Science and the Paratel company began to providing HPC as a service. The Jilan National Supercomputing Center is also working to transform itself to provide more IaaS services like big data, server, and storage, in addition to traditional scientific computing services. Last but not least, increasing HPC application will be containerized. The majority of HPC customers are, of course, not computer experts. Container technology can prepare the runtime environment well and decouple the software and hardware, making the HPC easy to use. In summary, these 6 trends, clustering architecture, heterogeneous computing, data-intensive HPC, IP-based network, computing as a service, and application containerization will make conventional supercomputing system upgrade from 1.0 to 2.0, from a simple computing provider to comprehensive data commercial value provider. That's my opinion.
Thank you. Very interesting discussion of the trends on convergence and virtualization of storage solutions and networking.
Yes.
My second question is, what does data-intensive high-performance computing mean to Huawei? And what are the principal characteristics and challenges for data-intensive high-performance computing?
Okay. As you know, data-intensive HPC is one of the important characteristics of supercomputing 2.0. Traditional HPC focuses on computing, just computing. Customers used to bring raw data on hard drivers to the HPC center and copy the computing result back on hard drivers. It's unnecessary for HPC center to restore massive data for long term. But things changed these years. Which will be the challenges? I will talk about the 4 main changes. The first change is that more data is involved in computing, in one computing procedure. The increased accuracy of the applications used for things such as weather forecasting and satellite sensing trigger exponential data growth. Data types are also increasing. In addition to structured data, unstructured data is also used for computing. For example, images are directly used for computing in electron microscopy applications. The second change accompanied with the dramatic increase of computing capability. This because of the heterogeneous computing. Now, it's impossible for a single task to consume or occupy all the computing resources. Therefore, multiple concurrent tasks are very common. For example, the HPC Center of Shanghai Jiao Tong University supports up to 15 parallel tasks, sharing 100 pflops computing resource. Some of the tasks are bandwidth type, while others are IO types, which require a more balanced HPC storage base. The third change is the higher reliability requirement. Traditional HPC is typically applied to scientific research, where it doesn't matter how many times a task is rerun, just need a correct result. But nowadays, HPC is used for more and more production systems, which require higher reliability and for both the result and the process. Here, the reliability of storage can meet the demands well. For example, a common way to guarantee the HPC procedure is to set breakpoints. Using the snapshots capability of the storage can make it more reliable to recover from the latest breakpoint. Fourthly, and most important, is the convergence of the supercomputing center and the data center. The supercomputing center is also providing multiple services such as AI computing, big data analysis, virtualization, and even disaster recovery service. Here, the biggest problem is data mobility. File storage for HPC, block storage for virtualization, object storage for machine learning, HDF storage for big data are all separated from each other. how to break the barriers and enable the data mobility is the biggest challenge facing to HPC Center. As you can see, all these challenges are data-centric. That's why I said supercomputing has gradually turned from computing-intensive to data-intensive. And I have to say, it's both a challenge and an opportunity to Huawei data storage. Thank you.
Thank you. And the third question is, what new technologies and products do you have at Huawei to address these challenges? And can you talk a bit about how the features map into some of the different application areas, such as you've already mentioned, including weather and other hybrid HPC workloads?
Yes. At Huawei Connect 2020, Huawei launched the next generation Ocean Store Pacific series to help the HPC industry better cope with the data-intensive challenges. First of all, is high-density design. High-density design is to overcome the first challenge I just mentioned. Based on the next generation high-density hardware, we launched the Ocean Store Pacific 9950 high-density performance model and Ocean Store Pacific 9550 high-density capacity model to deal with massive data increasing issues. The second capability is the hybrid workload balance. As I have said, more data is involved in computing. Multiple data types are involved in computing too, and the more data tasks are parallelized. So storage with more balanced capability is in demand. To meet with this demand, we launched a next generation parallel file system that supports both high bandwidth and OPS. Together with distributed parallel client, that is DPC, Ocean Store Pacific breaks the single stream and single client performance bottlenecks and helps enterprises cope with mixed workload challenge effectively. Multiple protocol interworking is the third capability. One of the key challenges of data-intensive HPC is data mobility. Ocean Store Pacific provides multiple protocol interworking. This means that multiple services require only one copy of data. This system provides protocols such as NFS, CIFS, HDFS, and S3 for on-demand deployment. What is the competitive is data written by one protocol can be read by multiple protocols without data migration, improving analytic efficiency. Huawei has been contributing to the storage field for more than a decade, thanks to our continuous investment and the trust of global customers. Huawei is now ranked top 3 in the global market share. Our Ocean Store series storage product and solution have been widely used in supercomputing industry. Luding Energy Norway uses Huawei Ocean Store to process and interpret earthquake data, achieving precision oil and gas exploration. In China, BGI chooses Ocean Store storage to effectively process massive genetic data, greatly benefiting people's lives. Therefore, I believe Huawei's Ocean Store Pacific product and solution can help more customers cope with the trend of supercomputing 2.0, especially data-intensive HPC. Thank you.
All right, this is very interesting. Your multi-protocol capabilities, your ability to have flexible allocation for both high density and for high bandwidth, and some of the other features. We have a few more minutes to talk. Is there anything else you'd like to add about the product features or performance or recent awards, anything that you'd like to talk about in the last 3 or 4 minutes.
I think the information have already provided. So I think we can talk freely. Just now that is true formally. we
Yes.
can talk freely. Yeah.
Yes. Okay.
Okay. Do you have any idea about the HPC industry?
Well, I think the AI activity, the move towards AI is the biggest meta trend that I see.
Yes,
And
I
of
agree with
course,
you.
tied up with that is the big data requirement that just goes right together hand in glove with AI. And of course, as you know, AI has got structured data and AI's got unstructured data. And so the flexibility to address both kinds. And people are trying more and more to do training with smaller data sets. Not everybody has access to the really enormous data sets that a few companies have. So the ability to address a more diverse set of data types for training and also for, for different sort of training models is I think important.
Yes, so it's really the time for the change of the industry.
Yes. Good.
Okay, I think I feel good.
Yes, I think we've filled up our time, and it's been a very interesting conversation. It's been a pleasure to meet you.